Welcome to the Deep Dive. Today, we're opening the door to something researchers are calling the next big leap in machine intelligence, cognitive artificial intelligence.
Yeah.
You're probably already bumping into generative AI all the time. The system's writing emails, making pictures. But this dive, it's all about moving beyond just spotting patterns or shallow connections.
That's really the heart of it. Our mission here is to unpack what makes cognitive AI so fundamentally different from the generative and, well, the purely symbolic models you might use every day. We're shifting the focus from just making output look plausible to actually embedding purpose, allowing the AI to grasp the why behind what you're asking.
Right, and that hunt for purpose, that's what takes it to another level. Cognitive AI is being built to replicate or try to replicate true human thinking, actual memory, deep learning, real reasoning. Current models, they're amazing pattern matchers, yeah, masters of correlation, but the output can feel brilliant and yet kind of empty sometimes.
Absolutely. Think about it. Their output can seem incredibly real, yeah, but often there's no real intention behind it because they're just predicting the next most likely thing based on statistics. Cognitive AI, though, it's aiming for comprehension, for pertinence. It wants to interpret and infer your underlying intentions.
Oh, so that shift from predicting the next word to predicting the user's intent, that's the core difference.
That's the game changer, precisely.
Okay, let's unpack this a bit more then. If current AI is already so good at spotting patterns in, huge data sets, what specific things does cognitive AI add to get to what you call deliberative thinking?
Well, it adds deliberation itself. The system's goal is to simulate how a person selects relevant information, learns from what happens next, in first context, reasons through a problem, and then responds in a way that's actually meaningful. And to do that, it needs dynamic access to information, recursive evaluations, kind of checking its own work, integrating different sources, and this is crucial, context, real context, not just the last few words typed.
So the system is constantly thinking about why it's doing something, not just what comes next statistically. That must totally change how you interact with it.
It really does, and it leads directly to genuine personalization. Your standard AI models often follow a pretty predictable path, almost like a script. Cognitive models, though, because they depend on continuous interaction and learning, they're shaped by your specific ongoing relationship with the AI.
Can you give us a concrete example? What does that personalization feel like in practice?
Okay, imagine planning a trip. A standard chatbot asks for dates, destination, the basics. Fine. A cognitive AI system, because it's building a model based on your experiences, might remember from 2 years back that you absolutely cannot stand layovers, you always prefer red eyes, and you only stay at certain hotel brands, even if you don't mention it this time.
Wow. So it pulls in history automatically.
Exactly. That kind of deeply integrated memory and learning, it creates continuity. It builds, well, maybe the closer bond sounds strange, but it models the AI on your specific history.
And if the system is built to act based on meaning and intention, are the researchers trying to build in ethical guardrails from the start? Seems important.
Oh, definitely. It's a major focus. Because the system is designed for this deliberative thinking, researchers are working hard to balance effectiveness with the ethical side. They're doing this by applying philosophical ideas like intentionality and meaning. The thinking is if the AI can reason about its actions, it should also be able to justify them, Make it observable, testable, a meaning-aware AI.
This is where it gets really fascinating for me. We keep saying context is the foundation, but what kind of context are we actually talking about? Is it just saving the chat history?
It's much, much deeper than that. We need to distinguish true contextual intelligence. This captures all those dynamic things influencing individual behavior. Context is the bedrock for these knowledge models. It's essential for keeping reasoning both compatible across situations and localized to the current one.
So it's not just knowing the time or where I am physically. Pragmatic cues, as you might call it.
Yeah, exactly right. We're talking about cognitive context. This brings in environmental signals, your behavior, maybe even mood indicators, and critically, knowledge of past events you've experienced, all to determine the correct, unambiguous meaning of what you input.
Right, ambiguity is a huge tripwire for current AI.
Totally. If I type, I want to go there now, current AI needs a lot more hand-holding. A cognitive system uses that stored past context to figure out there and maybe your current mood or situation to understand now.
That inability to handle ambiguity is a massive weakness in today's models. So how do these cognitive systems ensure context stays consistent if I suddenly switch topics or jump between apps?
Well, intelligent contextualization seems to rely on two main principles. First is locality, basically, using the relevant info from the immediate situation you're in right now. Second is compatibility. This is the clever part, maintaining the core knowledge model consistently through contextualization, even if you leap from, say, discussing complex financial stuff to asking about dinner recipes. The knowledge stays compatible across these different domains.
Huh. So if I'm asking the AI for advice on my investments, and then 5 minutes later I ask about my reading list, the core understanding of my risk tolerance or my favorite book genres doesn't just vanish, it stays consistent.
That's precisely the mechanism needed for that continuity we talked about. And we know this works because, well, humans do it all the time, naturally. There are experimental tests like dichotic listening studies that confirm these kinds of context mechanisms help us focus our attention. We prioritize relevant stuff over the noise. The AI is essentially mimicking that human filtering ability based on relevance and meaning.
Okay, so bringing this all together, how does this affect how the AI remembers me over the long term, but also stays current with the world changing all the time?
Right. So the system manages memory using two key dynamic parts. The first is called interaction context. Think of this as the persistent long-term memory of your individual preferences and behaviors. It's tied specifically to you. This is what promotes that continuity between different times you interact with it.
But hang on, collecting that much specific long-term behavioral data, doesn't that raise huge privacy flags? How does cognitive AI deal with that tension?
That's a critical point, and it loops back to why those philosophical and ethical frameworks, the justification part, are so vital. The data isn't just hoarded, it's used for computational self-modeling. The goal is to deliver genuinely personalized applications, think adaptive therapy, or tailored educational tools, where deep understanding and continuity are actually necessary for the system to be effective. The data is contextualized for use in specific, personalized ways.
Okay, so interaction context remembers me. What remembers the world outside me?
That's the second mechanism. Dynamic knowledge refreshing. This part is constantly evaluating and updating the system's knowledge about the external world. It adapts to new, sometimes ambiguous information in real time. This keeps it effective, especially in fields that change quickly, like maybe digital psychological interventions, adapting to new research or trends.
Got it. One mechanism is stable and personal, the other is dynamic and global. That's a good way to put it. And it avoids getting swamped by assigning importance scores to incoming data, kind of like human attention works. It prioritizes information based on relevance in a specific context, meaning over just sheer volume. It's this combination, the context-dependent recall about you, plus the constant updates about the world that lets something like adaptive digital therapy actually respond meaningfully to your mood or behavior right now.
It really sounds like building this kind of AI requires mixing different approaches. You need the fluid learning of newer models, but maybe the structure of older ones too.
You absolutely hit the nail on the head. Pure systems, whether just connectionist or just symbolic, tend to fail when you push them outside their comfort zone.
Yeah.
So yes, hybrid approaches are really taking center stage now. They combine connectionist architectures, your neural networks, with symbolic architectures, the ones based on rule and logic.
Yeah.
The idea is to maximize the strengths of both and minimize the weaknesses.
Okay, let's break that down simply. If I'm not deep in the tech weeds, how should I think about those two types of AI? Symbolic versus connectionist. Okay, think of symbolic AI like a very detailed legal code. It's robust, it's transparent, you can see the logic, you give it facts, it follows a rule, gives a clear answer, but it's brittle. If something happens that's not in the rules, it can just break or give a nonsensical answer. It doesn't adapt well. Connectionist AI, your neural nets, that's more like a highly trained specialist, maybe a doctor or even a skilled animal. It learns from vast amounts of data, spots patterns brilliantly, generalizes to new situations, it's flexible, but it's often a black box. You don't always know why it made a decision. And retraining it or adapting it quickly if the underlying rules change can be slow.
So the hybrid approach tries to get the best of both. The clear rules and structure plus the flexible learning.
Exactly. You combine them to get flexible, hopefully domain general architectures. And they can even teach each other a sort of reciprocal knowledge transfer. One specific way this is done is called stratified perception. It basically creates different layers of understanding, different levels of abstraction. These are needed to build up a kind of worldview and the contextual frameworks or schemata that are absolutely essential for complex reasoning and flexibility.
And is this hybrid architecture actually working in practice? Are there examples?
Oh, yes. A major proof of concept is an architecture called Clarion. It successfully replicated quite a few critical aspects of human cognitive architecture precisely by combining that role-based symbolic side with the adaptability of connectionism. It's a working demonstration that we can build AI that reasons in a way that's much closer to humans.
We seem to have engineered a brain that can reason,
Mm.
which naturally leads to the huge question, maybe the ultimate question. What's the line between building a cognitive brain and actually building consciousness?
Yeah, that definitely takes us beyond pure engineering and deep into philosophy. It's a really important question. While cognitive AI is getting good at replicating the physical and observable functions, perception, reasoning, making decisions, there are these profound underlying philosophical issues. Consciousness, intentionality, subjective experience, phenomenology.
Let's translate that. If the AI can perfectly replicate the outward signs of, say, being frustrated, what's the gap it still can't bridge?
The gap is the first-person experience, the what it's like. The AI can calculate the most appropriate behavioral response to mimic frustration based on its inputs and goals, but it can never actually feel the state of being frustrated. So these cognitive states, even if perfectly simulated functionally, lack real subjective content. Authenticity, maybe? The machine performs the function, but it doesn't have the experience.
So it looks like it wants something, but it doesn't feel the wanting. That's the intentionality problem you mentioned.
That's it exactly. We often interpret AI systems as having beliefs and desires because their behavior looks like it's driven by them. But really, those are just our beliefs about the system's programmed behavior. They aren't genuine, subjectively held beliefs by the AI itself. True intentionality seems to require that subjective, first-person viewpoint.
So where do we possibly go from here? How do we even start to bridge that huge gap between computation and consciousness?
Well, the consensus emerging is that for future progress, the purely computational and cognitive approaches must deliberately intersect with philosophy. We need to really grapple with intentionality, temporality, the sense of time meaning, and context from a philosophical angle too. Only then might we reach a truly robust understanding and definition for what advanced AI is or could be. Some researchers have even proposed a specific interdisciplinary framework for this, calling it Sophimatics.
Okay, so to wrap up our deep dive today, cognitive AI, it seems, is less about just processing massive data piles and spitting out statistically likely text or images. It's much more about achieving genuine meaning, real comprehension that's continuously tailored specifically to you, the user. And this is done through these advanced dynamic memory and context systems.
Precisely. This pursuit of meaning-aware AI, powered by things like interaction, context, and dynamic refreshing, it's already starting to change how AI is applied in real-time, highly personalized ways. It's transforming fields from education to mental health care by enabling machines to hopefully truly understand our intent.
So here's a final thought for you to chew on. If the ultimate frontier for cognitive AI hinges on solving these deep philosophical questions about subjective experience, the very challenge Sophimatics aims to tackle, how might developing that framework fundamentally alter our legal and ethical definitions of agency? What does it mean for a machine to have agency if it can reason like us but perhaps never feel like us? We'll leave you with that.